I think my favorite part of this entire project has to be this drawing right here. I feel like when I see someone using Excel to draw, it's like, okay, like a human did this. Like, in this world where everybody is using AI, it's like, man, like, am I looking at something that a human actually did? Or was it just like 100% AI? And when I see like the person using like this, because it looks like hand drawn and all, it's like a human did this. Now, don't get me wrong, I used AI as well, right? But, like, you gotta be tasteful with it. That's what I'm saying. Anyway, let's get into it. I'm Ernest, and I'm currently a data engineer, and well, I built this pipeline as like a personal project. It's just for fun. And this is the architecture of that pipeline. This is what the dashboard looks like. Cool looking, very nice. Okay, but let me just talk about the project. So it's based on food delivery. So think like DoorDash. Because I used to work at a food delivery company, it's called Delivery Hero. And this project draws from that real world experience. So imagine you're running a food delivery company and customers are ordering food and drivers are picking it up. Restaurants have to confirm those orders as well. So I've just like simulated the data for all that activity, and then the data gets sent into the cloud, and I clean it up and it lands in the dashboard. Let's go into the dashboard. So I built this based on metrics we use at work. Up top, we have these 5 KPIs, and we would check these like every morning. The managers, the heads, they would look at this because it's important to them. And total GMV, right? Let me just go through it. Oh, by the way, yeah, like they're all in yen, by the way. So it's all based in Japan. GMV stands for gross merchandise value, and you can think about it as your total revenue. And this is the total revenue for the past 30 days. We're looking at the past 30 days, by the way. So the orders by status, right? It's like an area chart, and it just shows us how many total orders we're having across these days, the trend, and we're also seeing the proportion of delivered orders and canceled orders. So if this red area starts to increase, that's like bad news, right? Like we need to figure out why are people canceling, right? Down here is our cancellation analysis. So we see, okay, one of the top cancellation reasons is like the customer waited too long for their order. Maybe it's because the restaurants are taking a really long time to prepare their order because it's peak hour and they're overloaded with a bunch of orders. So we need to talk to the vendor operations team, and then they'll probably call them, be like, hey, are you guys okay? Can we manage your workload somehow? And that's the process of things. Another one that I want to talk about is this, where time is spent in the order lifecycle. The order lifecycle is first you confirm the order, the restaurant prepares it, the driver picks it up, and then you deliver it. That's the order lifecycle. One thing that I saw in my previous company is that the pickup wait time was like really long. And then it's like, why? The driver just drives to the restaurant and then maybe they get there early. So once the order is prepared, then it's like you're already there. So just pick it up. I don't see how that would take longer than like 2 minutes. But what was going on is that some drivers would batch orders. They will wait for more orders to come in the app and then they batch them together so that they don't need to make round trips. They can go to a restaurant, go to another restaurant, go to another restaurant. And then once they get all the orders, you can go to the customer A, customer B, customer C. Just like one smooth trip. But as a result, there's a trade-off and the customers had to wait longer. We want the drivers to be able to work efficiently, but we also need our customers to receive their order fast. That would be something that the driver operations team, they would contact them and then they'll figure it out. So now let's talk about the pipeline. How does the data flow? Where does it come from? How does it get to the dashboard? We have a Python script, and this Python script generates our orders for us every hour. And it generates these JSON-L event files. And then we'll sync it into our S3 bucket. Why do we put it in S3? Why don't we just load it straight into Databricks and start processing, start cleaning? Well, in my case, you honestly could, just because you only have one source of data. But in real life, you'll have more than one source, 3 sources, 5 sources. In one of my projects, we have like over 50 sources. So let me illustrate. Imagine we have like more than one source, right? We have source A, source B, and source C for our data. And you say, hey, I'm just gonna point them all to this bronze table. What happens is that if this bronze layer ever fails, that's not good. Because then you will lose all your data here in the raw layer. And then if you want to bring it back, you're gonna have to reload all of this data. So we have like an intermediary layer or a landing layer, a landing zone. And so we just point everything to this bucket first. This is where we reconcile all our data, and now it's all in one place. If this ever fails, then it's like all good. We just load it back from our S3 bucket. It's basically just like fault tolerance. You just want to make sure that you're prepared in case this ever fails. So once it comes in here, then we load it all into our Databricks using autoloader. Once we load it into Databricks, we use a Spark declarative pipeline, or an SDP for short. Anyway, what is a Spark declarative pipeline? Okay, so think of it like this, all right? Think about cooking at home versus eating out. When you cook at home, you have to figure out every step. You need to chop the onions, you need to saute, you need to add some olive oil, and then you need to add the pasta, and then you need to cook it for 5 minutes, and then add this, add that. You're figuring out every step. But when you go to a restaurant, you say, hey, can I please have a carbonara? And then the kitchen does it for you. That's basically what an SDP is. Before this, you would have to write every line of code for every step that you were doing, and that would take a very long time. So the Spark declarative pipeline, you just define it. You just define it like one line. It's amazing. You just focus on the business logic, what the data should look like, and then SDP handles all the optimization and all that. All right, so by the way, this is what our pipeline looks like. You see, we have all these tables, and then we can see the lineage, right? This is our DAG. So all these bronze tables, these are the raw tables, and then we load this into our silver layer. Then for the gold layer, where we actually serve data to the end user, we have all these tables. Let me also show you what our data model looks like. If you notice, all these are the gold tables. This diagram just shows how they are connected together. Now, so once our data is all cleaned and all ready to be used, then this is our dashboard, right? It will query our gold tables to get all this data. It will query it using Databricks SQL Warehouse. So let's see, if I just click this, all right, you see that running low daily metrics is actually like a whole SQL query that they're running to retrieve the data so that it can reflect it back to you. And right now it's running, oh, I was just gonna say it was slow, but turns out it's not. Yeah, so it runs the query, it gets the data, and then it shows it to you. Literally amazing. Okay, so I also kind of want to talk about like what I learned doing this project. One of the biggest things is just learning to pick the right tools, learning to not over-engineer, learning to just like get things out. Let me show you, like this is the initial the initial plan that I had. And this was pretty basic. I kind of asked Claude, like, okay, like, what should we do here? And the first thing I got was, okay, like, we're gonna do streaming, all right? We're gonna generate 1 million orders a day, 50 gigs of data a day, and we're gonna get it all in real time. The moment it comes out, it's gonna be reflected in our dashboard. But then, like, I went ahead and did it, and then I realized, like, holy crap, that's a lot of data. Because if you do streaming, your cluster literally needs to be on 24/7. So think about this for a sec, all right? When I do batch processing, I am running our cluster for 2 minutes every hour. That's how long it takes to process the new orders. But if you are doing streaming, you have to leave the cluster on all the time. 60 minutes an hour. 2 times 30 is 60. Streaming is 30 times more resource intensive than batching in this case. So I just decided to keep it simple for now. This is V0, right? If I were to make it the next version, I want to add a new metric. So orders by status, we only have delivered orders and canceled orders. I feel like we can add on-time orders. So delivered orders will be separated into 2 categories. On-time orders versus late orders. Another one is maybe I might start adding in slowly changing dimensions type 2. Last but not least, if this is relevant, I will swap our autoloader. If I decide to go the streaming route, I will swap it out for Kafka to get true real-time ingestion. Okay, that's pretty much it. Let me know your thoughts if you have any. Like, I'd love to hear them.